Welcome, everyone. Thanks for joining us and thanks for being part of our community. My name is Ryan Heffernan and I'll be your host for today. A few reminders before we get started. If you're having issues viewing the live stream during the presentation and are using the browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Those two things seem to resolve most of the connection issues that people run into. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. By the way, all these links I'm going to be referencing here in my introduction are all pasted in the live event Q&A window. Closed captions in several languages are available during the live broadcast. You can enable them by clicking on the CC button located in the lower right-hand corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We love to hear your feedback on how we can improve these webinars, and you can give it to us at aka.ms/security-webinar-feedback. I would like to invite you to join our community by visiting aka.ms/security-community. That's the best way to ensure that you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in our private community at aka.ms/prseccom, requesting features, giving feedback, reviewing our product roadmaps, registering for events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a great topic for you today. We have special guests from our partner BlueVoyant. Micah Heaton, Ryan Moon, Stoney DeVille, Peter Hammermeister, and Michael Scutt will be talking about what threat hunting should look like in your Microsoft environment when using Azure Sentinel and M365 Defender. With that, I'll turn it over to them. BlueVoyant folks, the floor is yours.
Hey, thank you so much, Ryan. Really appreciate it. My name's Micah Heaton, and I'm the Director of Microsoft Security Solutions at BlueVoyant. We're thrilled and very grateful for the opportunity that Microsoft has given us to present on some of the insights and things that we've learned on our journey to help our customers maximize their security investments. Mike Scutt is going to be kicking us off today. He is the head of advanced threat detection globally at BlueVoyant, and I'll be kind of working behind the scenes, answering your questions and looking for opportunities to strategically interrupt this group in order to give some airtime to some of the better questions. With that, I'll hand it over to you, Mike. He's our general master of the defense against the dark arts, and really grateful.
Appreciate it, Micah, and I'm pleased to be joined by two of my colleagues, Ryan Moon and Stoney DeVille, who are content engineers with BlueVoyant in building out our detection library and automations, as well as a number of supporting functions for Azure Sentinel and M365. We'd like to kick off the presentation today with a bit of insight into how we write our analytics and how we approach detection. And as we were considering this topic, we found it pretty important to have a foundational understanding of the different types of detections that we write before we dive deep into threat hunting. There are a lot of building blocks that go into the foundation of our threat hunting program here, so we want to ensure that everyone can follow along. And initially, we'll start with why we focus on detection, why we focus on threat hunting. And the purpose is to best support our clients in detecting attacks as early as possible, but also identifying perhaps missing controls or preventative measures that they could be taking to mitigate the risk of a particular attack occurring right out of the gate. When we dive into building detections, we focus on a few key tenets here. We want to identify something malicious, certainly. We don't want to flood our analysts with benign events or false positives. We really want to try to ensure that when we're asking a human to look at something, that it's actionable, that it makes sense, that they have all of the background data needed to be able to make a decision. And if they don't, that we provide them the breadcrumbs, as it were, to identify any contextual follow-on events or preceding events that might allow them to say with confidence whether something is good or bad. And we focus quite a bit on accuracy and context. We have a number of programs and measures internal to our organization that allow us to track the efficacy not only of the rules that we write, but also the dispositions from an analyst to ensure that they have everything that they need, that they've made a wise decision, right? And a decision that matches ultimately what the client thinks and what we think. And from a context perspective, we try to pull in as many associated events or enrichments as possible to allow them to not have to copy and paste, not have to switch screens, and really have an entire end-to-end workflow within their analysis workbench so that we get everything, we can present it to a client in a meaningful fashion. And not only do the analysts know what they need to know to have an accurate disposition, but the client has the full narrative of events. So the attacker started here, they moved to these systems, and ultimately we were able to, interject ourselves at some point, or we were able to block, or in some instances, perhaps the adversary did get what they needed, but we need to be able to provide all of that information to our clients. And the way that manifests from a detection perspective is we focus on a few different types of detections, and they have very different use cases, and some are, in some instances, better than others. So when we identify an event, a new piece of malware, a new attacker methodology, we need to consider the amount of data that we have in support of a detection and the amount of data that we're going to need. When we identify something net new, whether that be through open source research or something coming from a partner or just generally a detection that was thrown out on Twitter or something like that, we'll often start with what we refer to as a discrete event detection, where we know something malicious, we have a hash, we have an IP address, we have this atomic indicator that's very precise, and we know what types of events are going to match against it. So we can build a detection that says, one-to-one, if you see this, it is bad. We'll also write discrete event detections when not enough is known about a particular threat or threat actor for us to detection that allows us to hit on edge cases. We'll often start with a discrete event. We know this is here, everything's on fire, we need to put it out. Let's write a very specific rule, we'll put it out there, see what we catch, and then going back to that context, look at all of the surrounding events and see if we can turn that into a more verbose or robust detection. Event detections. And those refer to a type of detection that accounts for multiple different data streams, or perhaps events that take place over multiple different individual records. And what we're doing there is, as we come up with a particular methodology, or we have something specific that we're trying to find that relies on us pulling pieces from all over the place, we sit back and we say, what data sources could contain the evidence that we're looking for? If it's a process, and we also need to know if there was successful command and control communications, likely we're going to have to pull in defender information. We're going to have to look at firewalls and IPS devices, and we're going to have to string all of those together into one query to determine whether there was success there, what the severity needs to be, and what other context we can pull for an analyst for them to perform their job, and also to provide that back to a customer and say, this was successful. We identified it on the endpoint. You need to remediate that endpoint. We also identified it in a firewall. There are mitigation actions associated with that particular firewall, and so forth. And lastly, we have what we refer to as algorithmic detections. These are admittedly a bit rarer for us because they're very comprehensive and they require quite a bit of care and feeding, as it were. But the purpose of algorithmic detections are really to identify concepts, the types of events, the types of methodologies, I should say, that we can't identify through a single event, or we can't even identify over the course of an hour. Perhaps it's methodology such as lateral movement, where we have to keep state of an entity. We have to know what a user logs into normally, how often, when, and so forth, so that we have this sort of state machine and historical activity we can use to identify deviation from that. Same concept as something like NetFlow, where if we want to identify on a suspicious increase in outbound traffic, we need to understand historically what that traffic was. So the algorithmic detections will often allow us to write for a very broad methodology and then narrow in, identify events of interest, and subsequently take those specific events, perhaps it was a tool that resulted in this NetFlow anomaly, and build that into a correlated or discrete event detection. So it's kind of a catch-all for low and slow or very nebulous sorts of attack methodologies. And now that we've walked through the high-level examples, I'll pass it over to Ryan to talk about what these actually look like when we implement them in our client environments.
Thanks, Mike. So as Mike said, these are used for very atomic indicators. So an IP address, a DNS, a domain name, a hash for a specific malware that we're going to get when a proof of concept is on the internet and released on the internet, or when a malware is released, identified in the wild, and deconstructed to identify these indicators of compromise, these atomic values. They are very fast because you're only looking for one thing in the string, or maybe a string of IPs or a string of domains. And so it doesn't take very long for the system to sort through a massive amounts of data. So these are good not only just for an alert in the future if it happens, but you could retroactively look through large amounts of data with a fast turnaround time to look for those indicators of compromise. And it's going to be very accurate because it is trying to match an exact pattern or a regular expression of a pattern. So we might not just look at a domain name of bad.com. It may be that the malware is using a bad1234.com and some numbers afterwards, and we'll be able to look for that expression even if it's not an exact match. So it's still going to be as accurate as possible from the details that we get either from the proof of concept or the malware that's released in the wild. Another good thing about these that are very discrete is that they're portable. So you could use multiple methods to store it on GitHub. You're able to release it online as a detection. You're able to even use programs like Sigma to convert it from one format with Azure Sentinel to another if you're using Splunk or any other SIM platforms as well. So you're able to share these individual events between not only within Sentinel and with people using Sentinel, but different platforms as well. So it helps to increase the visibility and detection rate for these zero-day compromises that get released as they first happen. Because the problem when you're dealing with these detections is they change very rapidly. The first proof of concept is going to have very discrete indicators of maybe an IP address, or they're going to use a very specific command line activity that could be searched for. But as they're adapted by adversaries later on, those discrete indicators are going to be modified slightly, and your initial discrete detection is no longer be able to detect that activity. And that's going to further feed into some of the other topics we're going to talk about later. And additionally, once we have these discrete detections, the analysts are going to receive this alert. They're then going to be able to look at what else happened with this alert and be able to hunt on further activity based on what they've seen with this initial indication. So we get an alert for a bad IP address. They're going to research this bad IP address is also running this specific command, and they're running this software. We're able then to build further discrete detections based on the information and the research that the analysts are able to do. So very good example of this one is on the next slide is when we had the Hafnium detection. So the first exploit, the first blog about it came out. It did not have a lot of details other than an executable, a process name. And so using that, and before we even notified our clients, we were able to issue a discrete detection for Hafnium based on the limited information that we had of the parent process name and any of the new process names spawned from that. And so an example you can see on the screen is this was a very quick detection that we wrote. It is very fast. It alerted us on new activity, but we are able to run this across the entire customer base to look for previous activity and hunt for any others that may not have been detected before we were able to put this detection in place. And as time went on, we saw more results from this. We're able to build better detections, and we're able to build better correlations and analytic rules that built on this. And so we combine this discrete detection with those other types of rules to build a better use case and improve the efficacy of these results until that they're able to be remediated by the clients and patched. And so now I think we're going to go on to a correlation event. Stoney's going to go in a little bit more detail.
Thank you, Ryan. Yeah, and so for the explicit signatures Ryan was talking about, it's a very transparent event. It's very explicit. It's very easy to see that this signature was bad. Then we move into correlated detection value. It's more of a translucent kind of world. Things start to get a little more fuzzy. It may not be an explicit signature, but it's the type of behavior that looks kind of bad. So if a user had several fails of trying to log in, and they were also, it looked like something malicious was downloaded and something else happened, then we're essentially correlating across multiple dimensions for behavior or data for that user. These things can be very contextual to a specific threat model, or they can also be tunable. We could say, if these things happened, but those things also happened, then maybe it's not so bad. It's also weightable. If several things, if many things happen, we can say it's critical. If only a few items happened, we could say it's low. And an example for that would be a brute force attempt. So this is very simply looking at the same source data on two different dimensions of time. So the first dimension is there were several fails happening or denies happening, followed by a success. And this can be done for the user. It can also be done for an external IP that's looking at several users in more of a password spray attempt. They're all very similar types of authentication detections we're looking at, but essentially it's a correlated detection across multiple dimensions. Sometimes it could be where several blocks suddenly happening for a firewall, and then also was a different data source telling us something else. That would be a different example. And then I think next is Ryan. Back to Ryan. What's our next slide?
Next is using an algorithm detection value. So this is not just looking at a discrete event or not looking at multiple dimensions. This is actually looking at an algorithm over doing historical analysis, building the statistical baseline over what happened. And this is ideal for looking for insider threats or attackers that are using off the land software. So a good example of this one, attacker may get in and they may be using a group policy. So an administrator may always use group policy and set group policy from his admin workstation. And you're going to have a list of every time he updates a group policy from his workstation. And so you'll see that time after time. He usually works from 9 to 5. He likes to take a 1-hour lunch break and he works from his system. All of a sudden, you're going to write a detection that's going to look for any anomalous behaviors against his normal baseline. But we can't just set that baseline in stone and it's never going to change. So we have to write a detection first to gather that historical data and store it in the system to be used for future detection. So now we know that the admin always works 9 to 5 from his workstation, and all of a sudden we see a new workstation pushing out a group policy object, and it's not so much outside of his time, but it's like 7 o'clock, so a little bit outside, something abnormal, but nothing too outside normal. And then the workstation is also called admin, but it's not his normal admin workstation. And so in this case, the detection algorithm would be like, that is a little bit odd. Let me continue looking for more activity and correlate it with additional activity on the box. Or it may be so abnormal that it's going to send that discrete event to the SOC or to your security operations center, or the security analyst to go take a look at that time. And so the idea is to build a baseline, build a database over what is normal for these users, and to continuously compare over what is currently happening in time to that previous activity.
Yes, and the algorithm section gets to where it actually gets even more fuzzy. The first section Ryan was talking about, it's very transparent as to bad is happening. The second section is where we're kind of correlating behaviors that still look pretty bad. And then into the algorithm area, it gets to where things are really fuzzy. And an example would be where we're collecting data across all of the different alerts that are firing by an entity, and then scoring that entity through time, through multiple dimensions. One would be the age of those alerts that fired for that entity, and those entities can be multiple. So it's not just a user, it can be an endpoint, it could be a file, it could be a hash file, it could be an application, it could be an OU group. Just to score the risk, or even a CIDR, right? Score the risk of a particular set of something that's relevant to a threat model. There's also severity of all of those alerts that fired. There's the class of the different types of alerts that fired. There are the relationships between entities. So you could score an entity being risky just simply because he's hanging out with other bad entities, even though that entity may not have been doing bad things. And then entity types. So you might score a file hash worse than you would a a user or something else because it just doesn't show up as much, and it might actually be more of the malicious item. And then determining severity. So looking and comparing how these entities that are scoring through that compare to one another, compare to additional external intelligence, so that we can see that over compared to different time frames. I might look for just today or over a longer period of time, and then score them as according to how they rank to everyone else that we're scoring, to see who's behaving the worst today versus yesterday, and then aggregating all of those into an alert. Is this behaving so badly? And there's also some true positives happening for this type of detection of these entities. Then all of that could escalate into an additional investigation.
And to peek under the covers a little into the implementation of our algorithms and our scoring, the way that we have actually implemented this is through a series of queries that are written initially to generate the types of data that we are interested in using for this larger aggregation. So we may have queries that collect a substantial number of benign events, logins, domains visited, as Ryan mentioned, group policy changes. Those are not the types of alerts that we're going to, not the types of queries rather that we're going to alert on, but we do store that data for use in downstream analytics. So it is an iteration of queries over time and then meta queries on top to be able to perform all of this scoring and ultimately come out with a top 25% of risky users, or a top user that we think that an analyst should be looking into. So within Sentinel, that's ultimately how we're doing this, is using queries to populate the data that we will use for follow-on queries that allow us to do scoring, aggregation, and subsequently alerting. And we've spoken about a number of different types of detections. When we get into actually trying to find something, we spoke about the discrete event detection. So I borrowed David Bianco's Pyramid of Pain because I find it succinct and just looks good on slides. But we'll often start with hash values, IP addresses, domain names, things that are very easy for us to detect, where we're looking at a discrete event. And as we work our way up into artifacts, what are the tool marks that are left by the adversary, the malware? What do we see in NetFlow or network indicators? That is where we start to get into our correlated data, right, where we're looking across multiple events. And then lastly, as we start to focus on the methodologies or TTPs that an adversary uses, lateral movement, or they change these configurations, things that are often benign, but in aggregate end up being something pretty fishy that we want a human to look into. That's how we've adjusted to ensure that we close as many gaps in detection as possible. And Ryan's going to walk us through how we do that at scale. We are an MSS. We have a number of clients. We have nearly 1 million endpoints that we're taking a look at. How do we make this customizable to each customer?
So one of the things that we identified as a challenge is we needed to be able to populate data that was on a per customer basis. So for example, on this slide, we have sanctioned DNS servers. In this case, as a MSSP, we may have company A, company B, company C, and they each have their own DNS servers. Well, they may have their customer name server that are actually listed as the name of their DNS server. So customer A.net, customer B.net. And we don't want to deploy a rule that lists all of our customers in those events and deploy that to all of our customers. So there's multiple ways that this could have been done, including now recently the watch list. But we have used what is functions in Sentinel to populate a list of data that will be used within the detections and the rules that we write. And so in this case, so now we just have a function placeholder, sanctioned DNS server, that will then populate the data for that customer and every customer that we deploy this rule for. for. And this enables us to have a couple of abilities. So we no longer have to keep track of DNS servers in 15 different rules that are looking for analytics against DNS servers. We are now able to create one constant, one function that lists all the DNS servers and able to deploy that, in this case, to 4 different rules that are using that same list of values. It helps us to maintain that list for the customers at scale. So in case customer changes their DNS server at one point, we could update it once and it'll update all the rules without having to redeploy them. And as I mentioned, there's several different ways to do this. Another way could be done at runtime. So as you deploy the rules with the ARM templates, you could templatize it enough that you could put in with Python or Ansible or any other scripting language and pre-populate the values before it gets deployed. But we found that using Azure Functions allows the customer and allows you the ability to update it live without having to redeploy the rule. And the next use case of these is to reduce the noise. And so in this case, we have several analytic rules that are looking for, could be potentially malicious, live off the land activity. So a good example of this one is an admin creates a new user or an admin changes a user's password. Those are normally very benign activity, but there's usually a very set group that is allowed to do that, usually a help desk or maybe admin 1 that usually always does that. And so you could put that one admin that is authorized to do that activity in a list. And so you don't necessarily have to alert on it anymore. You may make note of it for future RBA or for future analytic detections, but you don't have to go look at that user doing it. And then if another admin takes his place for a day because he was sick, then you might get an alert and you might add that new admin into the list as well. And so that's going to reduce the noise and the false positive rate that you have to go identify just by being able to populate this information in these suppression constants. And so that way you're not having to relook at old data over and over again.
We've walked through the methodology behind our detections, but we didn't talk about one aspect yet, and that is threat hunting. And threat hunting is really there to bring human expertise into the analysis process with the understanding and the assumption that adversaries will get by our detections. It's very, I think it's very rare that we run into a situation where an attacker hasn't done one little thing here or there or changed something up where we identified one portion of what they did, or maybe we identified 7 out of 8 events, but that eighth event still required a human to go in. We also don't know what we don't know. And with that, we focus on threat hunting. When we start working through our threat hunting hypotheses, what are we going to run? What are we going to look for? We find it's best to move into the attacker mindset. If I were a bad guy and I knew what detections were deployed, how would I circumvent them? And then look for that circumvention. Similarly, if we're looking for a particular type of attack or a class of malware, we would go and do a bit of research into what the common elements may be or what tool marks and forensic artifacts are left behind through the execution of that malware. And lastly, going back to that behavior anomaly detection, users don't typically do what? Based on the role of a user, they may not run PowerShell, right? So we want to go look on PowerShell on all non-IT systems and just perform frequency analysis or look for uncommon flags or downloads. And when we're doing this, we're often looking through a substantial amount of raw data. So we do enrichment on it. We have our alerts. We are also interested in getting it straight from the source. Tell me everything that ran on the endpoint. I don't need you to filter it. I don't need you to tell me what's of interest. I'll make that determination. I have a few kind of experience-based spidey sense things that I'm going to look for, so I'm going to dive in and take a look. And ultimately, the way to think about how we perform threat hunting is that it's an incident response engagement without having an initial lead. It's a compromise assessment. We go in with the assumption that there's malware or there's an adversary somewhere until that is disproven. So we're constantly evaluating and refining hypotheses, brainstorming new ones until we are comfortable and confident that there isn't any adversary activity that was missed by our detections. And that is an ongoing process for us. And really, what we're hoping to do there is find this little gap between the controls that are put in place by our clients, be those preventative measures or process-based controls, the detections that we have, and finally threat detection. We're not only looking for the gap, but we're also trying to identify anywhere that the controls that our clients have put in place, preventions and these sorts of things, to determine whether someone's trying to subvert them. Even if they're unsuccessful, that's a very strong indicator that something malicious is taking place. Somebody is trying to turn off Defender, they're trying to disable monitoring tools, they are trying to move laterally to systems where they don't have access. Those are the types of things that we're going to look at to say, we may have an adversary that is unaware of the preventative controls and they're knocking up against them, and this is our opportunity to identify them and kick them out very early in the process. And we have to keep a few things in mind as we're building hunt hypotheses. One, ultimately our adversary is human. Even if it's an automated script or it's compiled code, at the end of the day, there was a human behind them. And those humans create patterns, they make mistakes. These are all the types of things that we look for. So if we know that a particular threat actor always compiles and the debug path for that executable is this particular directory or this username, these are the types of little nuanced consistencies that we can use to hunt for. We also know that when we have a hands-on keyboard adversary, an interactive adversary, they tend to do things in a particular order. They type commands in a particular way. Those are the other types of activities that we're looking for as we're trying to scope it out. So we know what an admin does every day, per what Ryan was referring to with the algorithms. And furthermore, because we have all of the telemetry, we know how they type commands. We know what order they pass flags to netstat. When we see deviation from that as a threat hunter, we know either they're trying something new, they fat-fingered something, or we need to dive in because this isn't actually the admin with all other things looking normal, just different enough to make us not confident, inconfident. The other core part of this is if you don't collect your data, you can't hunt against it. And this is a pretty big one. When we ran into all the activity, the Hafnium activity with Exchange, one of the big issues there was we had to go back and pull Exchange logs because it's not something that's often collected and often stored because it's just an application, right? But in this instance, we really, really needed it. We were able to ultimately hunt against it because those logs existed on disk. But if you don't collect it, if you don't persist it somewhere that an adversary can't get to it, you can't really hunt on it. And lastly, we consider the intrinsic elements of an attack or the intrinsic elements of what an adversary has to do. There are certain things when an adversary gets into an environment they don't have to do, but it's very likely they're going to perform reconnaissance, they're going to enumerate groups, they're going to try to find systems of interest. We want to heavily focus on some of those very early signs because that gives us the best opportunity to identify an adversary through hunting before the scope increases, before they have the option or opportunity rather to get their heels into the environment and really stick in. And lastly, out of the intrinsic aspect, we all hear about sophisticated attacks. We hear about APT groups. We hear about this stuff every single day. With the majority of the work that happens through those adversary groups, despite the fact that they're very good at what they do, a lot of it's very simple early on. It's bringing off-the-shelf tools. It's running reconnaissance commands. It's using binaries that are built into an operating system. So we tend to focus there before we get to the point of them bringing in a brand new implant that has this crazy network, command and control algorithm that we can't figure out. We try to hit them when it's simple and then follow them as they go. Tends to make our life a little bit easier. And what that funnel looks like as we go through our hunting hypothesis creation is we pick a couple of different phases that we're going to focus on, or a couple of different types of detections. One are common elements. For a given malware family, yes, there will be a change, but often behind those different instances of a malware family, there is a builder or there's a single system that's compiling them. If we can find the consistent elements of that, we don't spend our time chasing every new invocation of that and every instance of Cobalt Strike with a different C2 IP. We look at the common elements of that malware family, of that piece of code, and use that to write a detection to more or less build something robust and help give us confidence that we'll be able to detect it. Similarly, we want to know what tools are out there. What are folks using? This often comes from Twitter or watching red teamers or kind of digging into investigations to figure out during root cause analysis what the adversary did before we caught them. How did they perform recon? Did they bring advanced IP scanner in? And we focus on the types of tools that they use so that we can write detections against those specifically. We will find instances where there is a lot of benign activity for tools like PsExec or ProcDump, but we take the good and the bad. We know that there's going to be noise. We just rely on expertise and the aggregate of weird things happening to tell us if it's actually bad. The next is looking at the adversary activity in the kill chain. And what that means is as we identify various aspects of an attack, we try to identify as close as we can where in the kill chain that adversary or that event took place so that we know where we have to go next. If we caught them very early on in reconnaissance, we know that preceding that was a method of ingress, and perhaps prior to that was internal or external reconnaissance. Similarly, if we see them drop an implant or we see them exfiltrating data, we know we're very late in the attack chain. We know that we have a lot of root cause analysis work to do to determine the fullest extent of that compromise. And lastly is anomaly detection. So where do users deviate from their normal behavior? Where's a system deviating from its normal behavior? This tends to be a little later in the attack, in the kill chain of adversary activity, but it is once again that aspect that allows us to say, hey, we haven't really found anything bad so far. We don't have a definitive, indicator of evil. So let's go look at some anomalies and see if there's perhaps something we've never seen before taking place behind the scenes. And Stoney's going to walk us through a bit of what that looks like, that risk-based or anomaly-based aggregation.
There are basically two main areas of aggregation type analytics for detecting bad. One is on the right here, user behavior anomaly. Most of us all know it as user behavior analytics, UBA, maybe EUBA. But generally, if you're in this space, you spend a lot of time there, it's mostly all anomalous behavior. And Sentinel now has the user behavior anomalies detections that are firing, and they're really cool. They have some sliders. They're a little black box. They're a little hidden, but there are some sliders that can be adjusted. However, the algorithms themselves are not exposed, and so. But generally, in this area of user behavior anomalies, it's looking for what is normal behavior, and then suddenly what is not normal. And in that space, abnormal behavior is very normal. There's oftentimes we all behave abnormally in a normal fashion, right? Or we normally behave abnormally. So there's a whole lot of possible, false positives or benign activity in that space, and it takes a long time to tune it. Generally speaking, where we find most value is in comparing a user's profile. There are two main areas we know. There are system accounts, or there are systems behavior, and there are user behavior, right? And so there may be crown jewel systems and then everything else. There may be crown jewel users and then everything else. Sometimes the crown jewels are the C-suite. Sometimes they're the finance department. So sometimes you ask a question, why is the behavior of a front desk personnel or a cashier suddenly behaving like a developer, or like the marketing department uploading lots of files, which would be normal for them? Why is this system that is normally very loud at this time of day suddenly behaving very loud like a different system? And combinations of users and types of users within these different systems. So that's where it just becomes anomalous based on a baseline of normal. That tends to be somewhat of a subset. If you go back just go back once. I just want to touch on risk-based alerting first. So risk-based alerting, though, is different in that it's UBA light, maybe. It's also all of the detections or rules we may have looking for bad behavior. So if I say you failed a lot, you have downloaded a lot of bad things, or you look like you have a high score of doing bad things, like I was talking about on previous slides. So that's really it's a different way of looking at users and systems and entities, and the user behavior anomalies can be a subset of those risk-based alertings. Okay, next slide. So then on anomalous aggregations is where you essentially are pulling together multiple anomalous behaviors and how you may map to other entities, either in your OU group or in other users that are your peers, and how someone may have, or a system may have, crossed over. There's also threat modeling for those. So this anomalous behavior followed by that anomalous behavior followed by another, and then being aware of coverage. Just because I have detections across the entire kill chain doesn't mean I actually have the data for it. It doesn't mean that it may not even fire. So just looking for 7 out of 8 events for a threat model is not always the best thing to do. It might be 2 or 3 in the right order throughout the chain. So.
All right, so how do we do this at scale? Well, Microsoft has a great Python library called MsticPy, and it allows you to run either the queries that they have built in, or you could run your own custom queries that you wrote and just run it like you would in Sentinel itself. Fantastic tool, but it allows you, it's only built to allow you to use a config file and to run it against one customer at one time, and you get the results for that one customer. Which wasn't in our use case. We wanted the ability to be able to search across all customer bases, so we don't only just get the data for one customer, we could get the data for all customers. Or in some small organizations, maybe have multiple log analytic workspaces or multiple Sentinel environments that you want to query at one time. So for an atomic indicator, say you get an IOC of an IP address, you don't want to just search one of your environments, you want to search all of them at once to see if you have any hits for that indicator. And so what we did was we wrote on top of Jupyter Notebooks with MsticPy the ability to pull in the configurations and the credentials for all the workspaces, run a query against all of them, and to aggregate all the data into a single Python Pandas data table. And this allows us to do the analysis without having to run the query again multiple times. So we have all the data in a giant database stored in Python, and using Pandas, we can manipulate it, we could create graphs, create charts. We could do all this great stuff to analyze, do the analytics on it, to look for that anomalous behavior as we're hunting. And it worked very well, except when it came to a few challenges when we started moving into M365 hunting and credential management, credential access for those environments, and then trying to maintain that configuration and credentials for all the customers just became a little bit of an issue. So it just became a scale problem at that point. But it worked fantastic. It was great for being able to identify activity at scale across a large number of workspaces. So taking what we have learned and the issues that we identified and the things that we needed and wanted to improve on, we developed another ability to create our own kind of tool sets to do this without using MsticPy directly. And this also enabled us to kind of create our own framework for a hunting rule. So we have the query that's going to be used to hunt for anomalous activity across all the customers. And within the rule, as I kind of talked about before, one of the options for putting in the whitelist and the exclusions and the constants is instead of actually putting it in the customer environment or putting it in your environment, you put it in the rule itself that's stored in some repository for storage. And then you're able to use that and to dynamically create the exclusions as you run the rule and the tool sets. And so you're able to then pull back all the data and analyze it as you see fit. Within just one screen.
And bringing this all together, what it looks like at the end of the day, when we have all of these disparate queries and different detection types and different screens, right? At the end of the day, this all has to come together in a usable fashion for an analyst. And in some instances, for automation where it's high confidence, but ultimately, as we bring all of this together, we perform aggregation, it has to make sense. We have to have a way to align things. And certainly we can do so by the timestamps of events. We are doing this in some instances by the aggregation of risk, regardless of time. And also, as Stoney mentioned, by kill chain itself. So we can identify where something is. We can identify the order of events, and then assign a kill chain to them and present that and say, this is where we are and this is what you need to do. An example of this between hunting, RBA, and this whole aggregate detection story that we've been telling you is these independent queries being used to generate events of interest that we can then use to aggregate. In hunting, those queries look very similar to RBA, something like remote executable transfer. We may not want to see every one of them, but we certainly want to know that that happened in the context of another event. But if we see a remote executable transfer and then we see command line scheduled task creation from the same entity, we can assume an attacker has pushed an executable to another system. They created a scheduled task to run it, essentially creating their own version of PS exec, as it were. And then we see them downloading data over the command line. We see weird port and protocol connections coming in from firewalls and endpoint data. And then we see unsanctioned IT applications like procdump. So from a hunting perspective, we look at all of these on a per entity basis in a timeline and say, this looks really not good. It may not be anomalous for the user. It may be, we're not looking at it from that context. This is truly experience-based. We know from all of our engagements, this order of events means someone is either trying something out and being creative as an employee, or we have an actual adversary on a system that's pushing malware around or tools around and executing them using scheduled tasks, dumping creds, and all of the other things they do in their workflow. When we add that to the RBA alerts that also fire for multiple logon failures, we have password resets, we have an account that was disabled becoming enabled on an entity of interest, we have multiple RDP connections coming from the single system, once again, that entity of interest fanning out to a bunch of other systems, and then successful login from an IP and failure from a different, which tells us that adversaries are using different infrastructure to try to move around. When we bring this all together into a timeline, it becomes compelling. It starts to sort of self-document. An analyst is looking at this saying, my confidence in this being benign is now about 2 to 3%, right? We have a lot of very interesting events taking place here. We have hunting rules that were specifically defined as to catch malware. And now that we've combined it with RBA over time, we see somebody transferred an executable after trying to fail to log in. They created scheduled tasks. They downloaded something over via HTTP, via the command line. They reset passwords, so on and so forth. And ultimately, shifting down this time frame, we see that over the course of 2 hours, we had a successful compromise with lateral movement, live off the land binaries. We see them attempting to log in from other infrastructure now that they have a foothold in the environment. And when we present this to an analyst, they have the majority of the context that they need. They're still going to have to dive in, certainly, and validate the results of some of these queries just to double check. But ultimately, what we want is for the analyst to be able to look, say, this is bad, make a disposition, and take action in a very short amount of time. And as we bring all of these aggregations together, what we're really trying to do here is close all of these gaps, make it very difficult for an adversary to hide in an environment without making some noise. Some alarm is going to fire somewhere. That will get aggregated up. We'll have an analyst look at it, and hopefully we've made a disposition and chased them out. So anomalies, looking at oft benign activity, but stuff that's noteworthy, right? It sits and just kind of boils until we see something of interest or it starts to bubble up. We have known bad in our discrete detections. You're using this piece of malware, you're communicating with command and control, or you ran Mimikatz or something on a system, which we can identify pretty precisely. And then we have an unknown bad. We need to go threat hunt. We need to go see what else might be happening in the environment. Maybe it's a new persistence technique, it's a new malware family. We have to chase in, bring all these together, and ultimately alert. And we'll leave you with a bit of insight into how we come up with the ideas for all of these little micro queries and analytics that we build. We break them down into various aspects of the attacker kill chain against various system types. So from ingress, what are the types of things we can look at? We're looking at authentication. We're looking at weird host names, user agents. We're looking at access to sensitive resources in SaaS providers, cloud or on-prem. And we're going to write detections that don't immediately alert off of those unless they're high confidence, but they gather all of that context we need for that aggregate alerting. Similarly, with execution, what are the different ways that attackers can do that? What operating system tools don't we really use? Do we not use Dameware or PSExec or REMCOM in our environment? Those are things we want to flag. Persistence, same. We know that they're going to persist at some point, unless it's all in memory and they just want to disappear. So we're going to take a look at all the different scheduled tasks and services and other aspects that they can create there. We take a look at every single application token that's added to any user account across all SaaS platforms, because it's rare, it's often benign, but we want to know it's there because we know adversaries use it. And then lastly, looking at lateral movement, what are the different ways, what are the protocols, what are the applications that we associate with this, and how can we pull these all together into discrete detections, algorithmic detections, correlated detections, and threat hunting. And I hope that we've left everyone with a solid idea of how to implement this or the ways to think about implementing these types of detections in your environment.
Hey, thank you so much, Mike. What an awesome presentation. In fact, we did have quite a few questions, and it turns out that those questions were asked before we really got into the threat hunting section. So a lot of the things folks were curious and interested about, the group actually happened to answer back for them. I'm going to take a moment just to recap the questions and provide the answers. Feel free to offer some additional insight here. If you don't feel like you got the answer to your question and we don't adequately cover it here in the next few minutes, please feel free to connect with any of us on LinkedIn. It's obviously very clear at this point, this is a group of super threat detection nerds, and I mean that in the most endearing professional sense. So we would happily have any of your connections today. One of the first questions that came up, guys, was from somebody who was saying, what are the ways to start when you've got a new use case? Like, what's the actual place to start? And I want to really reiterate something that Mike said earlier, folks, which is you can't actually do meaningful threat hunting without the data. And he said something really important, which is if it lives on the disk, you can always go and grab it. But from the context of working with the service provider, that data collection apparatus is incredibly important. The monitoring is one piece of the story, and they really covered that quite well, I feel like. But in order to do meaningful threat hunting, they simply need the information. I think a very technical term that Mike used was spidey sense. And I'll just make the suggestion that your spidey sense grows in strength the more information that you have collected and is at your disposal. Is that fair to say, Mike?
I think that's spot on. And that is ultimately how we start this, is we have new hypotheses, is we initially have to determine what we're trying to find. And often we can get that from various research articles or GitHub repositories, or actually executing some types of frameworks we know adversaries use to gather information. Once we know what kind of tool marks, we now have what we need to go and discover the data in which those tool marks may live. So the initial hypothesis to get there is, you have an idea of what you want to find. You have to figure out what types of data it's going to be represented in, and then you have to go ensure that you're collecting that data. You identify the systems that may contain it, and either query them directly or pull them back to a centralized repository like we do, and then start hunting.
Thank you, Mike. The next question we'll quickly recap here was from Arshad, and Arshad was asking, if a file hash isn't actually available in an IOC, how do you go about creating detections or finding zero-day vulnerabilities? And Arshad, I think that Stoney and Ryan, in fact, actually had a good kind of lead in on Microsoft's perspective on this anyway. The impression, or I would say the likelihood that a zero-day vulnerability is creating some kind of activity that can be associated with the risk aggregation that Stoney was talking about is probably pretty high. So I'm going to let Stoney just kind of capture this in a moment, but Stoney, do you think that the opportunity across the suite of Microsoft security products to do really meaningful risk aggregation is not something you see in the competition in the marketplace? And could you also just kind of share your personal feeling about how valuable that kind of risk aggregation is? And Ryan, certainly feel free to weigh in as well.
I think that the ecosystem of security products that are fairly tightly integrated inside of the whole Azure ecosystem is very beneficial, mostly because all of the entities have somewhat of a normalized mapping that's happening across everything. And there's even all these little hidden configurations where you could say, you could check the box to connect MCAS with DATP or MDE, and you can connect MDE with Azure Security Center. So you might get an alert at MDE, and you're also getting an ASC, and you're also you can get it in so many different places that you can really like have multiple votes, like belt and suspenders, and a lot of crossover, multiple votes. That this is definitely happening from multiple systems, and then have all those entities mapped together. So yeah, it's and then you can add to that. So any of the custom detection rules we write in Sentinel, they can all be mapped to the entities. So you can just keep adding on to that really nicely. So yeah.
That's awesome.
That looks around the signature, the explicit signature that's happening. And if you're in a small environment, you're probably not getting a lot of 0 days. But if you're big, you might see some first in the wilds. You know, I mean, it's first in the wilds anyway. You know, usually just pay attention to what's happening on 0 days and look for them immediately.
So Ryan, how important do you think it is to be able to basically over a short amount of time use the suite to map patterns of normalized behavior so that you can see pretty quickly departures from that baseline? How valuable is that from kind of a content creation standpoint as well?
It's very valuable. So I've been able to take like initial indication from a blog post or a write-up from a malware researcher, identify some very particular points I want to go research and query across the environment, and not just like the logs I'm getting in Sentinel, but I could do the same thing across all the MDE, the Office 365, the entire Microsoft suite. And so I'm not just limited to looking at what logs I may be collecting. I could go proactively query the other systems in the ecosystem to look for not only activity that is happening in the past, but then put rules in place to look for activity in the future.
That's awesome. Thank you, Ryan. Stoney, Mike as well. Really appreciate your time. Really grateful for your expertise. So look forward to the opportunities that I get to learn from you. I would encourage everybody here that would like to connect. I've actually even seen quite a few connections come in on my phone just from this presentation live. So I would encourage everybody to reach out and ask each one of these folks when it was that they decided and knew they wanted to find and fight evil throughout, you know, the digital landscape. Really appreciate everybody's time. I'm going to hand it back over to our host, Ryan, if need be, and just want to say thanks to everyone and look forward to the next one.
Fantastic. Thank you. I want to thank all the folks behind the scenes who are help answering questions and making everything work. Of course, I want to thank Micah Heaton, Ryan Moon, Mike Scutt, Stoney DeVille for a fascinating presentation. This was really great, guys. I appreciate it. Most of all, I want to thank all of you for joining us and being part of our community. Please be sure to check out the recording. We'll be posting that at aka.ms/security webinars. And also there you can check out our upcoming webinars. So we hope to see you next time.